All right, Chem 1 kids, a promise made is a promise kept. So here is your very first video lesson of the year. We're going to start this before we start Unit 6 because this is a key skill that you're going to need to have to do this unit. It's called dimensional analysis. All right, so first let's talk about multiplying fractions. When you multiply fractions together, you're going to divide the product of all the numerators by the product of all the denominators. Now you probably already know how to multiply fractions, but just in case, let's look at this. Now we're also going to do the same thing for units. So if we look at this example, we see that we have 2 and 3 in the numerators of the two fractions to be multiplied. So we'll simply multiply those numerators together and get a brand new numerator and do the same thing with the denominator. So when we multiply 2 times 3, we get 6. And that becomes our new numerator. And when we multiply 9 by 2, we get 18, and that becomes our new denominator. Now we can just solve using our calculator 6 divided by 18 to get 0.33. Now here's an example using units. And so we have 3 grams divided by 5 milliliters times 45 milliliters. Now, we don't really think of 45 as being a fraction, but any number is really a fraction. We just don't see the denominator. We could say that 45 divided by 1 is 45. So any number will be part of a fraction that will have 1 as the denominator, assuming that it's not something else. So to solve this problem, we'll multiply 3 by 45 to get our new numerator, and 5 will still be our denominator. So 3 times 45 divided by 5 is 27. Now let's look at what happens with the units. We have grams divided by milliliters times milliliters. Now when we multiply those units together, the milliliters will be in the numerator and the denominator, that unit milliliters. And we know that anything divided by itself is 1. So essentially, the milliliters will cancel each other out. And the only unit that doesn't cancel is grams, so the unit of our answer will be in grams. All right, so what is dimensional analysis? Well, dimensional analysis is used to convert one unit into another. If we want to convert grams into pounds, we would use dimensional analysis. Now, to use dimensional analysis, we use something called a conversion factor. A conversion factor is just an equality that can be turned into a fraction. Now, once you have fractions, like we just learned, you can multiply them together to make the conversion. Right? So we're going to arrange all our fractions in a way that makes it so that all of the units cancel out except for the one, that we are asked to solve for. Too many Oreos. All right, so here's an example. I know that there are 5,280 feet in 1 mile. We can then say that 1 mile is equal to 5,280 feet, or 5,280 feet is equal to 1 mile, because those distances are equivalent. Right, so we can take that equality and turn it into a fraction. So we could say that the fraction would be 5,280 feet per mile. And it would look like this, 5,280 feet over 1 mile. We could also turn that fraction around and say that we have 1 mile per every 5,280 feet. And if we did that, the fraction would look like this. So let's see how we use this conversion factor. The question says, how many miles are there in 7,392 feet? So I know I'm going to have to take my original quantity and use the conversion factor to convert it into miles. Now, we want feet to cancel out when we perform this calculation. So we have to make sure that we have to choose basically which one of these fractions we're going to use, right? And we're going to have to use the one with feet in the denominator because we're going to want feet to cancel out. So we'll put 5,280 feet down here, and in the numerator we'll put 1 mile. And feet will cancel out, and you'll be left with miles, and specifically that's 1.4 miles. And that makes sense because if each mile is about 5,300 feet, then 7,400 feet would be about 1.5 miles. All right, so to simplify things, we use something called the fence. Right? So a fence literally just looks like a fence. And the horizontal line in the fence will represent division, and the vertical lines will represent multiplication. So here's an example of a fence. We see that we have the horizontal line and the vertical lines. Any numbers that are on top of each other will be divided by each other, and any numbers that are adjacent to each other in the fence will be multiplied. Essentially, all we're doing is, all these are is a bunch of different fractions, and the vertical line represents the multiplication sign. So let's just throw some numbers in there. Now, if I want to solve this problem, I basically just have 5 fractions multiplying together. So again, we're just going to take the product of all the numerators to get a new numerator. So 3 times 5 times 3 times 11 times 3 will equal 1,485. And we'll do the same for the denominator. 2 times 5 times 1 times 2 times 9 is 180. So when we solve, we get 8.25. Now there aren't any units in here, but we'll look at examples with units coming up. All right, so we can see as we saw in the last slide, use more than one conversion factor at one time. All right, now every time we use a new conversion factor, it will be its own fraction. So let's look at a good example of doing this. So I want to know how many seconds I have been alive. Right? All I really know is that I'm 38.7 years old. So I'm going to need to use a bunch of different conversion factors to convert years into seconds. Now, I don't know how many seconds there are in a year off the top of my head. So I can't make that equality that says 1 year is this many seconds. But I do know that 1 year is 365 days. Now, I also don't know how many seconds are in a day. Right? So I'm going to use another conversion factor that says there's 24 hours in 1 day. Now, again, I don't know how many seconds there are in an hour, so I will say that 1 hour is equal to 60 minutes. And I know that there are 60 seconds in 1 minute. Right? So I'm going to have to use all 4 of these conversion factors. Now, to determine how many I'm going to need, let's think about it in advance and think about how many different conversions we're going to make. Well, we're first going to convert years into days using this conversion factor up here. Then we will convert days into hours using this conversion factor here. Then we will convert hours into minutes using this conversion factor. And finally, minutes into seconds. So if we're going to be multiplying or using 4 different conversion factors, then we're going to be multiplying by 4 different fractions. That means we're going to need 4 rungs in our fence. So let's actually do this problem. So the first thing I will always do is draw my fence. Now, I figured out beforehand that I'm going to need 4 rungs, so I'll draw 4 vertical lines in my fence. Now, I always put a smiley face in the bottom left rung because the first fraction will always consist of the thing that we're given. And usually, in fact, always, it will be a number, not a fraction. So we just put the smiley face down there just to remind ourselves that we don't have to put anything down there. So the first thing I need to do is convert years into days. So I'm going to use my conversion factor that says 1 year equals 365 days. And I'm going to put 1 year in the denominator because I want years to cancel out. Because I'm trying to find the number of seconds, the only unit that shouldn't cancel is seconds. Now that I'm at days, I have to convert days into hours. So I'll say that 1 day is equal to 24 hours, or there's 24 hours per day. Now, I put days down in the denominator so that they would cancel. So now I'm going to put 1 hour in the denominator and 60 minutes in the numerator. Finally, I know that 1 minute is 60 seconds. So before we actually solve, we should make sure that all of the units cancel out appropriately so that the only unit that doesn't cancel is the one we're trying to find. So I see years cancels with years, days cancels with days, hours cancels with hours, and minutes cancels with minutes. The only unit that doesn't cancel out is seconds, and so I can say I'm 1.2 times 10 to the 9th, or 1.2 billion seconds old. All right, so metric conversions. There's a few metric prefixes that you're required to memorize. Now, many of you guys are native Spanish speakers or are taking Spanish or taking French, or you can speak Portuguese or Italian or whatever. Okay, so that knowledge should help you memorize these conversions. So in 1 meter, there are 100 centimeters. Now, how do we remember that centimeter means 100? Well, the Spanish word for 100 is cien, which sounds very, very much like cent. So there's 100 centimeters in 1 meter. Now, this now can be used as a conversion factor to convert meters into centimeters or vice versa. In 1 meter, there are 1,000 millimeters. Now, I know that in Spanish, the word for 1,000 is mil, which sounds very much like milli. there are 10 decimeters in a meter, and I know that the Spanish word for 10 is diez, which sounds very much like deci. And finally, in a kilometer, there are 1,000 meters. All right, so these prefixes, centi, milli, deci, and kilo, can actually be used on any metric unit. Here we use them with meters, but if we wanted to do it with liters, it's the same thing. 1 liter would be equal to 1,000 milliliters. 1 liter would also be equal to 10 deciliters, and 1,000 liters would be called a kiloliter. All right, so here are some examples. The first one says convert 32 grams into ounces. Now it gives us a conversion factor that says 28.3 grams is equal to 1 ounce. So the first thing we'll do is figure out how long our fence needs to be. So we're going to go from grams to ounces. And I see that my conversion factor can do that in one step because I have one that connects the number of grams to the number of ounces. So we're only going to need one rung in our fence. We'll input our given quantity in the top left and our smiley in the bottom left. Now I have to know which fraction to use. I have the option of putting 1 ounce in the numerator and 28.3 grams in the denominator, or vice versa. Now I will put grams in the denominator because I want grams to cancel out, and I want to be left with a unit of ounces. So when I put that in the denominator, that's exactly what happens, and we should get just over 1 ounce, and we do 1.13 ounces. All right, the next example says convert 52.5 inches into centimeters. And again, I'm given a conversion factor that connects the number of centimeters to the number of inches. So again, I'm only going to need a fence with one vertical line in it, one rung. The given quantity is 52.5 inches, and I put my smiley down below it. Now, when I input this conversion factor, I will put 1 inch in the denominator and 2.54 centimeters in the numerator. That makes it so that inches cancel, and I'm left with centimeters. I'm sorry, that should say centimeters, and the answer is 133 centimeters. Obviously, I did a lot of copying and pasting when I animated this thing. All right, here's another example. Now, this is a multiple step problem. Right? We know that because it asks us to convert 5 kilometers into centimeters. Now, when I showed you all of those metric conversion factors, we did not have one that went directly from kilometers to centimeters. So let's plan out what we have to do first. Now, if I know the number of kilometers, since I have a conversion factor that tells me how many meters are in a kilometer, I can convert kilometers into meters. And I know that there are 100 centimeters in a meter, so it seems to me like we're going to need 2 conversion factors for this problem. So I will draw a fence with 2 vertical lines in it. We'll input our given quantity and the smiley face down below. Now's where you have to know those metric conversion factors. They're not going to be given to you like on the previous problem. You just have to know them. So I know that in 1 kilometer, there are 1,000 meters. And I know that for every 1 meter, there are 100 centimeters. Now, before you put this into your calculator, you should check to make sure that all of your units cancel. And indeed, the kilometers cancel, the meters cancel, and we're left with centimeters. So I see that 5 kilometers is 500,000 centimeters. And that makes sense because 5 kilometers is probably about from, I would say, probably South Lakes High School to Herndon High School, right? So that's a lot of centimeters. All right, now finally, here's a crazy example where we're just going to compare the different numbers of fruits together. But it works in exactly the same way. It says, how many pineapples can I get for 30 oranges? So we have to look and see if I have any conversion factors that connect the number of oranges to the number of pineapples. And then if I don't, I have to figure out how many conversion factors I'll need, and thus how many rungs will be in my fence. So if I look here, I see that I have only one conversion factor has oranges in it. And it tells me that there's 4 oranges for every 5 pears. Now, there isn't a conversion factor that goes directly from oranges to pineapples, so I'm going to have to use more than one. So now that if I can convert to the number of pears, I see that I have a conversion that says that there's 1 pear for every 2 melons. And there's another that says there's 3 melons for every 2 pineapples. So if I convert oranges into pears, and then pears into melons, and then melons into pineapples, then I will need a fence with 3 rungs because I'm going to use all 3 conversion factors. So I'll input my given, input my smiley face. Alright, so now we'll start throwing our conversion factors in. Since I'm starting with oranges, the first conversion factor I'm going to use has to be the one that has oranges. And I'm going to put the 4 oranges down in the denominator so that oranges cancel. If I put 4 oranges down below, that means I have to have 5 pears up above, because we can only put in the conversion factor, both sides of one conversion factor. Now that I have the number of pears, I can convert that to melons by saying that 1 pear is equal to 2 melons. And I know that there are 3 melons for every 2 pineapples. Now let's check to see that our units cancel before we solve. Oranges cancel with oranges. Pears cancels with pears. Melons cancels with melons. Pineapple is the only unit that remains, and that is exactly what I'm asked to find. So my answer becomes 50 pineapples. Now again, to solve this, we're just going to take 30, multiply it by 5, times 2, times 2, and then we're going to divide by 4 times 1 times 3, and you get 50. All right, so on Blackboard, there is a practice worksheet. I gave this to you guys to work on in class, but if you were absent and are watching this video to get caught up, then download the worksheet and see if you can do all those problems by yourself. All right, well, thank you for watching my very first Chem 1 video. Hopefully these will help you guys to study and to do better in general, and bring any questions you have to class. And again, thank you for watching.